Okay, everybody, here's our crash course on the Behringer X32. So far, you've all been using an analog Mackie board that has all the buttons exactly where you can see them. Everything is in plain sight. Digital boards do everything an analog board does, but with added layers. You aren't going to see every button because they're hidden behind a user interface. Sometimes it's a touchscreen. X32 looks like it has a touchscreen, but it actually isn't. The dials and buttons will get you through these menus, of which there are many. Let's go over the basic layout. Your inputs are on the left. You have 16 faders that you can control at once, which is similar to the Mackie 1604. On the Mackie, input 1 on the back corresponds to fader 1 on the top of the panel. On the X32, the contents of fader 1 will depend on what layer you're on. These buttons on the left represent 3 potential fader banks. These faders can represent channels 1 through 16 if you hit this button. If you hit the next button down, they will shift to channels 17 through 32. There is a third bank that shows auxiliary channels. There's an aux 1 through 6 RCA and quarter-inch input section on the back. Some USB playback channels and your effects returns will show up here. For the purpose of the recording studio, you'll be dealing with the first layer. We have 3 mics that will show up on channels 1 through 3. The rest of the board is also doing stuff to route the student computers to the studio speakers, but that's not something we need to deal with in order to record. So that is the input faders. You have buttons above the faders that resemble what's on the Mackie and most other boards. Mute is self-explanatory. Solo will send a pre-fader listen signal to your headphones. And select will allow you to start configuring individual channel settings. What do I mean by that? Let's look up above the faders to the channel strip. On an analog board, every channel will have its own dedicated gain knob and EQ knobs and aux send knobs. 16 channels, 16 gain knobs. On a digital board, you have 1 knob each that can control whichever channel you have selected. So, if I select channel 1, I can adjust the gain on the very first mic. It is an infinitely rotatable dial. On an analog board, once you rotate it all the way, you've maxed it out. On the X32, the LEDs will tell you when you're maxed out and can go no further. When I go into the next channel by hitting select, the LEDs will adjust to whatever settings are on channel 2, which are likely different than channel 1. Again, these knobs can be for any channel at all up to 32, so you need to pay attention to which one you actually have selected. It is easy to make a mistake when you think you are adjusting a setting on a specific channel, but you've selected a different one. A digital board has a lot more options than an analog board, but that also means there are more places in which things can go wrong if you are not paying attention. Anyhow, up here you have your gain knob, a low-cut EQ filter, a noise gate, a compressor, a parametric EQ, and some bus send knobs. We haven't talked a lot yet about gates and compressors, so don't worry too hard about those. A gate is for shutting out signal until it reaches a certain volume, and a compressor is for keeping signals from getting too loud too quickly. A parametric EQ is a more precise and configurable EQ than the ones, say, on our Mackie. The bus send knobs are the equivalent of aux send knobs on our Mackie board. Bus is another type name for an output, but it behaves similarly to an aux. You have 16 bus sends, which could be thought of as 16 potential speakers. As it were, the Sound Studio buses 9 through 16 go to our 7 UPM speakers and subwoofer under the table. So which input goes to which bus or output is going to all depend on the application. We will come back to outputs in a moment. I just wanted to point out these knobs on the channel strip. Next to our bus send knobs is a send out to our main outs. Unlike the Mackie, where main left and main right have their own socket on the back, these mains default to come out of output 15 and 16. You can unassign them completely to where they don't do anything at all, which is actually what we're doing in this case. We are using bus 15 and bus 16 to go output 15 and 16 because it is way more consistent number-wise. So for this use case, you can ignore your main bus and the corresponding main output fader. It literally does nothing. While we are up here, you have a slot for a USB drive. You can save copies of a board file on it, save board recordings, or use it to update the firmware. We don't really use this honestly, but it's there. Okay, that was our left side of the board. On the right, we have faders for our outputs. Similar behavior. You have a bank of 8 faders that will change function based on which button setting you have active. It can be bus outputs 1 through 8, or bus outputs 9 through 16. Matrix outputs are another kind of output. What it does is slightly more complicated, so we will have to talk more about how to use matrices in the future and not right now. DCAs we will also have to talk about more later, but the idea is, DCAs are for customizing how an operator mixes a show. For example, you can group the whole band on one DCA fader to raise and lower their volume as a whole. Or you can put all the female chorus members on one fader because there's like 12 of them and you can't control them with only 10 fingers. On the right of our output faders, you have more assignable buttons. You can program these knobs to do whatever. And you can program these buttons to do whatever. There's 4 knobs and 8 buttons, but you have 3 banks, A, B, and C. So it's more like 12 knob configurations and 24 button options. It's a mixer's choice on what they do. So ultimately, you don't really have to concern yourself with this whole section. They are just extras. What happens here isn't going to make or break your audio. Mute groups. You can assign these buttons to quick mute any combination of inputs and outputs that you want. Like if I program mute group 1 to silence all of my vocal mics. Mute group 2 could be a mute for all of my speakers, like a panic button. Mute group 3 can turn off the whole band, and so on and so forth. Scenes. So something that you would expect to be able to do on a digital board that you cannot do on an analog board is save settings and reload them during a show. For example, at the top of my show, all of my mics are out, muted, nothing. That's scene 1. I can recall scene 2 whenever I'm ready to raise mics 1 and 2 to a volume of -10. Scene 3 can take them out. Scene 4 can raise mic 3 to a volume of -5 over the course of 3 seconds and add reverb because it's a ghost. Scene 5 can quickly take that out. We call this method flying faders. You've got buttons here for previous scene, next scene, undo, and go. View will take you into the scene menu on the above screen. The screen is the hardest part of the console because it's got so many tiny internal menus inside more menus. So, before we look at that, let's briefly touch upon the rest of the buttons nearby, for the record. You have a monitor section. We can theoretically plug our studio monitors into this, but we're just using regular outputs to keep things streamlined and make more sense. So, this monitor level knob doesn't do anything for us right now. The headphone knob would do something for us if we had headphones plugged in. On a show, yes, we would probably plug in headphones. Here in the studio, we do not have any plugged in. The mono button will sum your audio to mono if you wanted to hear it like that in your headphones or stereo monitors. Again, it is not relevant in this particular use case. Dim is a quick volume reduction. It is an interesting lighting term for audio that I haven't seen anywhere else, a button to make the sound dimmer. Next to monitors is a spot for a gooseneck light and a talkback mic. We do actually have a talkback mic. However, it is plugged into a regular input. Again, this was a choice to be more streamlined and less confusing. You have a volume knob for your mic and an option to send it to 2 different places, A and B. If we use this, which we aren't. One more button that actually is relevant, quite relevant, sends on fader. It is another option on how to send your inputs to your outputs. Instead of using these knobs over here, you can enable sends on fader mode, which will start blinking. Using the select button to choose an input, you can decide with the faders what kind of volume you are sending from your input into any of your 16 outputs. For example, mic 1 is sending out to logic at a volume of very loud. You can see it here on the knobs, or you can see it on sends on fader mode. The analog equivalent for the bus send knob is cranking an aux dial on an input channel, but there's not really an analog equivalent for sends on faders. So I recommend clicking through it and thinking about what is going where and why until it starts making more sense. It will click eventually. Okay, here's the most complicated part of the board: the display. The buttons and the knobs are generally going to make sense because they don't move around and have little labels underneath. The screen, however, is going to change depending on what menu you're in. And there are a lot of menus. I'm not going to go through every menu because I'm just trying to get you familiar enough with the board layout that the buttons and the knobs can generally make enough sense as to why they are there and what they could do for you, and to get you familiar enough that you can set levels for 3 microphones and record them into Logic. I started to try to detail each little menu and what it all is supposed to be doing. I have to stop myself because not all of it is relevant to what we're trying to do, and I don't think getting into the weeds of why you can make your buses pre-fader or pre-EQ is helpful information right now. If you are a sound student, I encourage you to poke around the menus. You will possibly see this board out in the field somewhere. It is not a bad one to learn, but we are not going to learn this whole thing today. Okay, so that's the surface layer of the X32 board, not including the display and its internals. How do we get those microphones into that computer? Let's go over signal flow. I'm here in the vocal booth. I have 3 microphones on stands. They have XLR cables running along the floor into this AVP. They are plugged into microphone inputs 1 through 3. Behind that panel is house wire, so conduit. It actually goes into the floor and spits out into an XLR snake. Channels 1 through 3 of that XLR snake plug into 1 through 3 of the X32. From here, you want to be in layer 1 through 16. Select channel 1, and it will correspond to microphone 1, which is the MXL 990. You can control the preamp level here on the gain knob. You're not going to hear anything without your computer on, however. Internally in the board, mic 1 is routed to bus 1. Mic 2 is routed to bus 2. Mic 3 is routed to bus 3. Buses 1 through 3 are labeled on the output side as logic 1 through 3. If you look in the output routing, bus 1 through 3 are sent to user out 1 through 3. And user out 1 through 3 is further configured to card 1 through 3. Card stands for slot card, which is the Dante card on the back. It is an extra that we have installed in the back of the X32. Dante goes from this board into this network switch. From this network switch, you are also connected to the Mac Pro on the floor, so you are getting audio from the mics out the Ethernet cable into the computer. In Dante controller, X32 output 1 through 3 is routed to Dante Virtual Sound Card 1 through 3. In Logic, our audio input is Dante Virtual Sound Card, or DVS. There was a Logic template, but it seems that somebody saved over it several times with weird extra tracks, so you can start a new file and add 3 tracks for 3 mics. If you wanted to try and see the difference in frequency response that each mic choice makes, I'm going to speed through setting up inputs 1 through 3 on tracks 1 through 3. And when I am ready, I can walk into the vocal booth or tell my friend in the vocal booth that we can set a level. Adjust your preamp on the X32 accordingly, and that is your recording signal flow. Good luck!